In this video, we talk about the galvanic cells. So our objective for this lesson is at the end, we are expected to be able to describe the function of a galvanic cell and identify its components, and also to use the cell notation to represent the galvanic cell and its components. In the 1800s, Alessandro Volta, an Italian physicist, invented the first modern electrical battery, which was known as the voltaic pile. And it was through this voltaic pile that he was able to show that electric current may be generated from chemical reactions. Okay? Chemical reactions will generate electric current through the voltaic pile. This invention of Alessandro Volta was a momentous scientific breakthrough, providing the first constant source of battery and enabling many other advances in the study of electricity and how it relates to chemical reactions. So this study between the interconversion of electricity and chemical energy is called electrochemistry. In electrochemistry, electricity can be generated by movements of electrons from one element to another through chemical reactions called redox reactions. So this time we understand nganong kinahanglan nato mag-review sa redox reactions for us to be able to understand better how electricity is generated by the movements of electrons. Now, the generation of electricity through the movements of electrons take place in devices called electrochemical cells. Electrochemical cells are constructed in such a way that the device contains all the reactants and products of the redox reaction, but there is a very big but here. There is no physical contact between the reactants. So you might ask, banga, how does the chemical reaction take place if there is no physical contact between the reactants? Giun sa pag-react. Giun sa pagkahitabo sa redox reaction. But you will find out later how it happens. And because of this redox reaction taking place without the physical contact between the reactants, electrons are transferred directly from one species to another. Electrons are not transferred directly from one species to another, but instead, the transfer takes place indirectly through an external circuit that connects the separated reactants. Okay, so meaning even if there is no physical contact between them, there is an external circuit which allows the passage of electrons. So we are going to study two types of electrochemical cells. We have what we call as the galvanic cell, or otherwise called as the voltaic cell, and we have the electrolytic cell. So what's the difference between the two? So galvanic cells or the voltaic cells are electrochemical cells where spontaneous reaction generates electricity. So galvanic, spontaneous. And for electrolytic cells, these are electrochemical cells wherein electricity is used to bring about a non-spontaneous chemical reaction. So, meaning in galvanic cells, it's from chemical reaction to produce electricity. But in electrolytic cells, electricity causes a chemical reaction. Okay? So we understand unsa nang spontaneous and non-spontaneous chemical reaction. A spontaneous reaction is a reaction that occurs naturally under certain conditions, and non-spontaneous reactions are those that do not take place unless it is driven by a continual input of energy from an external source. So kasabot naman ta ana. So let's talk about the galvanic cell first before we go to the electrolytic cell. In spontaneous redox reactions, electrons are transferred and energy is released, diba? Chemical reaction takes place producing electricity. So this energy released can be used to do work if the electrons are made to flow through an external device, meaning walay physical contact between the reactants. If there is a physical contact between reactants, walay energy nga ma-release ana. nga maalaw nga mo do work. So this can be achieved through a setup called the galvanic cells. So galvanic cells, as I said earlier, are otherwise known as the voltaic cells because it's named after its inventor, Alessandro Volta. So these are electrochemical cells, as stated po ganiha, in which spontaneous redox reactions produce electricity. So what happens in a galvanic cell? So it directs the transfer of electrons in an external pathway instead of directly between the reactants. The reactants force the electrons to travel through a wire, and it uses oxidation and reduction reaction occurring at two terminals to change chemical potential energy to electric potential energy. And so kanina siya ang pwede mo do og work. This energy released can be used to do work. So what are the components of the galvanic cell and how do we set up the galvanic cell? So electrochemical cells are composed of electrodes. So electrodes are two solid metals connected to each other by an external circuit where electrons will be made to flow. So two solid metals. We have two electrodes in an electrolytic cell. So the first electrode is the anode and the second electrode is the cathode. Always na ay anode o cathode. It's impossible nga an electrolytic cell doesn't have an anode or a cathode. So pair na silang duha. So it's always at the anode where oxidation occurs. It's always at the anode where oxidation occurs. And it's always at the cathode where reduction occurs. So oxidation meaning the electrons are lost, and reduction meaning where electrons are gained. So what happens is, whatever electrons are lost at the anode will pass through the external circuit and will be accepted or gained at the cathode. So meaning, from the anode to the cathode ang movement sa electrons. But these electrodes used, there are two types that we can use. They're either reactive electrodes or inert electrodes. So reactive electrodes are those electrodes used that will participate in the reaction. So if it's the anode, if it's a reactive na anode, they will eventually disappear. So electrode participates in the reaction and will gradually disappear as the reaction progresses. But if it's the cathode, there will be a build-up. And if it's an inert electrode, so this is a conducting material. Inert gani meaning it will not take part in the reaction. So mura na difference sa duha. Reactive, it will take part in the reaction. Inert electrode, it will not take part in the reaction. So, diba, as I said, ganiha, it's impossible nga naay anode, it's impossible nga isa ra ka electrode ang naa in an electrochemical cell. So, they always go together, the anode and the cathode. But we cannot expect that these two electrodes will always be reactive. Diba, kay electrodes are supposed to be solids. But we can't expect that all reactants are solids. Sometimes they are in liquid form or sometimes they are in gaseous form. So liquids and gases cannot be used as reactive electrodes. So what should be used para mo take place ang reaction are inert electrodes. So these are solid materials, but usually they are made of platinum or graphite, but they do not take part in the reaction. Unsa may role niya? They just serve as a surface where electrons are transferred. So kinahanglan man gyud og surface, kinahanglan man gyud og electrode. So avenue lang siya para mo take place ang reaction. In other words, gigamit siya for the reaction to take place. Okay, so first we have the electrode. The next component of the galvanic cell are the half cells. So naay duha ka electrodes, and in an electrochemical cell there are also two half cells. So a half cell is composed of an electrode immersed in a container filled with an electrolyte solution. Just imagine it as a beaker with an electrolyte solution and then an electrode is immersed there. So this electrolyte solution is a solution that generally contains the ions, atoms, or molecules that have lost or gained electrons, and it is usually conductive. So there are two half cells in a galvanic cell, one that contains the anode and the other contains the cathode. And lastly, we have the salt bridge. Third, not the last but we have the third one. The salt bridge. It's an inverted U-shaped glass tube plugged with a glass wool at each end and filled with a weak electrolyte solution that does not take part in the electrode reaction. So we have two already nga dili mo take part sa reaction. First, if ang gigamit kay inert electrode, and this one, the electrolyte solution nga naa sulod sa salt bridge. Okay, but it's an electrolyte solution. So unsay gamit sa salt bridge? What is the use of this weak electrolyte solution inside the salt bridge? So it's used as a connection between the oxidation and reduction half cells. And the main purpose of this is to prevent the buildup of ions on one side of the cell. So the main purpose is simply to balance the charges. Because diba, in the anode, there will be a loss of electrons. So if the anode will keep on losing electrons, what will happen to this half cell? It will become more positive, right? And then the electrons will go here. So as more electrons is gained at the cathode, it becomes more negative. So it's not balanced anymore. So kinahanglan na ay mo balance sa charges. And that is the purpose of a salt bridge that is connected no sa duha ka half cells. And of course, lastly, number 4, I just didn't write this, but number 4, we have the external circuit here. So we have a wire here and we have a voltmeter attached to make the reading of the voltage generated by the chemical reaction. But those are the main components. So how do electrons flow through the cell? So as discussed, the electrons are produced in the anode by the oxidation half reaction. The anode is considered as the negative pole of the cell. It will pump the electrons into the external circuit, meaning it will produce man siya electrons. And then the electrons that are generated from the anode will move through the external circuit, which is connected to a voltmeter, and then will go to the cathode, which is the positive pole of the cell. So anode is the negative pole of the voltaic cell or galvanic cell. The cathode is the positive pole of the cell. And then it will happen to the electrons. The electrons are consumed at the cathode where the reduction half reaction happens. As the half reaction proceeds, the positive ions tend to build up around the anode, as I said, diba? Because it will keep on losing electrons. And then the cathode becomes deficient in positive ions, meaning the cathode will become more negative as it will keep on accepting the electrons lost by the anode. So to maintain the electrical neutrality, the cations and anions in the salt bridge must move toward the cathode and the anode. So diba ang cation kay unsa man na siya ang positive nga that's the positive nga ion. So because the cathode is more negative now, so the cations, ang positive, muy moadto sa negative to supplement the lack of positivity there. The anion is negatively charged nga particle. It will go to the anode which is more the anion, which is a negatively charged nga ion, negatively charged particle, will go to the anode which has become more positive already. So cation to cathode and the anion to the anode. The positive ion to the more negatively charged electrode now, and the negative ion will go to the anode which is the more positively charged now. Okay, so it is represented in this figure, the flow of electrons. So, this is our anode. Okay, this is X, substance X, and this is, okay, substance Y or metal Y. So, these two are considered, we assume that these two are active, no, reactive nga electrodes. So, they will take part in the reaction. So, this anode will lose electrons. So, pag lose niya og electrons, X man siya. So, i-lose niya og electrons. So, mahimo na siyang X plus diha. Y man. If X, that's a solid, and it will lose electrons. So, asa man nato ibutang ang electrons diha sa product nga side, diba? Igawala, kung minusan siya og electron, mahimo na ning X positive. AQ, diba? Kay zero man ni siya. Zero man ni iyang a charge diri. Kuhaan siya isa ka electron, mas daghan na ang positive. So, as this substance, as this anode keeps on losing electrons, kani nga electron, ari na siya mo flow diri, the more nga magsigi og form aning X nga ion. Munang naanay build up of positively charged ions here, as X nga anode will keep on losing electrons. I hope you understand that. So, the electrons will pass through the external circuit, and then kani ang voltmeter, basahon na niya kung pila na generate nga voltage, and then it will go here. So, si Y, it is not this substance Y that will accept electrons because that is already stable, complete na siya. But instead, ang ions in the solution ang mo accept sa electrons. Diba? Okay. This is the half cell here. This is the half cell. This electrode is immersed in this half cell. This blue color here is the representative of the electrolyte solution, no? This is a solution here, nga gidip sila. So, this solution contains the ion of this electrode. So, kung X ni siya nga electrode, so, napod tayo X ions here. So, meaning kung Y ni siya nga electrode, napod tayo Y ions here. So, kani siya, kani man siya ang kulang og electrons, this is not kulang of electrons, kani si cathode nga electrode. So, this is kulang man, so kani si Y plus, it will go to, ano siya diha, kay, yan na emit ang electrons. So, this Y plus AQ will accept an electron to form a Y nga solid. So, meaning, as the reaction progresses, magkaanam og ka hurot ang mga Y nga positive nga mga ions diri because it will keep on accepting the electrons nga na transfer from the anode. So, what will happen is ma-deficient na ni of positive ions here, the more nga ma-negative ang kaninga half cell here. And we don't want a build-up, dili man na pwede nga na-build up of positive and negative ions on each half cell, na i-imbalance, so kinahanglan siya i-balance. So, the anion here, which is a negative nga ion, and the cation here, which is the positive nga ion, will go, kani si anion will go here para mabalance, kay positive man eh. Positive and negative, diba? Para ma-neutral. Same here, kani positive, moari diri sa mas negative na para ma-balance. So, if the electrodes to be used are active, ang anode will eventually be used up. Mahurot ni siya because it will keep on losing electrons. Sige siya form aning positive nga ions. And because there is a build up here, mubagga ni siya diri. This will thicken up because there will be a formation of solid. Okay? Muna siya ang electrodes. This is what happens in a voltaic cell or galvanic cell. So, we have here a concrete example of what will happen in a reaction, a redox reaction. So, in this figure here, we have a zinc metal. So, this is a zinc metal. and it's placed directly, no? It's placed in a copper sulfate solution. Okay, that's a copper sulfate solution. If you see a blue solution, meaning na siya copper class, kay copper blue man na siya. So upon contact, as we can see, upon contact on this picture here, zinc undergoes oxidation. It will lose 2 electrons which will go into the solution to form a zinc ion. So if you notice, unsa may indicative ana nga ni-form na siya og zinc ion, nagkaanam na pud siya og kawala ang color. If you notice, the color is now not so blue anymore. And then, because also, kay ang copper dire ang nakakause ani nga blue nga color, ni undergo man sad siya og reduction. It undergoes reduction as it gains the electrons lost by the zinc to form a solid copper metal, which is what you can see here as what is formed on the surface of zinc nga metal. Magsige na siya form diha hantod mahurot na to si zinc, and then ma-replace na siya ni copper nga metal. So this is a redox reaction. The oxidation of zinc and the reduction of copper, and this is the overall cell reaction. But in this reaction, there is a direct contact between the two reactants. There is no electricity generated in the reaction. Wala. But still, if we use zinc and copper, if we make zinc and copper sulfate react, kani mo happen gihapon ning zinc, oxidation of zinc and reduction of copper, but through a voltaic cell, naa siya electricity nga ma-generate. So how? So like this. So if the given spontaneous redox reaction between zinc and copper is made to happen in a voltaic cell, electricity is generated. So what happened in this figure? So here, diba sa atong previous nga example, si zinc ang ni-undergo og oxidation, and si copper ang ni-undergo og reduction. So si zinc atong ibutang as anode, og si copper atong ibutang as cathode. Okay, so they are active nga electrodes. So zinc is immersed in a solution, a zinc nitrate solution. So let me write the formula for that. So that's ZnNO32AQ. So that's zinc nitrate solution, and here we have copper nitrate solution. So muni ang mga solutions wherein they are immersed. So as zinc is oxidized, as zinc loses electrons, the electrons will pass through the external circuit going to the voltmeter and going here, except siya diri sa cathode. So si zinc will keep on losing electrons, and it will keep on forming this, diba, Zn2 plus nga ion. So magsige na siyang build up diha og Zn2 plus, Zn2 plus, Zn2 plus, because it will keep on losing 2 electrons as it will keep on oxidizing. And also the copper ion here in the solution, copper nitrate, will keep on accepting the electrons lost by zinc. So munang mas negative ang charge here. And so this is the salt bridge. There is a plug here. As you can see, there is a cotton nga plug here para dili mo flow ang solution itself, but it's just the ions that will go. So the more positive naman siya diri, so it's the negative that will go here, and it's more negative na here, so the positive will go to the cathode. So eventually, over time, zinc will be used up, and there will be build up sa copper. So muni siya ang voltage nga iyang ma-generate. So the zinc metal serves as the reactive anode immersed in the zinc nitrate electrolyte. The reactive cathode is a copper metal immersed in the copper nitrate electrolyte. The salt bridge connecting the two half cells contains sodium nitrate, which does not participate in the reaction. An external circuit with a voltmeter connects the two half cells. So once the circuit is closed, once na natong ang salt bridge, once na ang voltmeter, nakakonect na ang external circuit, once na close siya, zinc will automatically undergo oxidation. So zinc anode loses electrons, Zn2 plus ions are formed and goes into the electrolytic solution, making it more positively charged. The electrons lost by the zinc anode will pass through the external circuit and goes to the copper cathode. The copper ions in the solution receives the electrons and forms copper metal, which is deposited on the copper anode. The electrolytic solution becomes more negatively charged. So to balance the charge of the now more positively charged anode half cell and the more negatively charged cathode half cell, the sodium ion in the salt bridge goes to the cathode half cell. Positive man siya, moado siya sa cathode half cell. And the nitrate ion goes to the anode half cell. And the voltage generated is read using the voltmeter. So this is another figure showing what happened between zinc and copper. So Zn2 plus ion goes into the solution. As oxidation occurs at the anode, nga nilose og electrons, flow through the reduction occurs at the cathode, where the copper ions in the solution will gain the electrons, forming the copper nga solid sa surface sa copper nga cathode. So this is what happens in the koan. This is an actual photo of the two electrodes nga koan. So this is a closer look at what happens in the electrode. So the zinc anode is used up and the copper metal is deposited on the copper anode. So kanus siya mo end if you disconnect the circuit, or if the zinc anode is already used up. Hurot na ni siya tanan.